In this lecture, we look at the calculations used in the determination of the analyte from a titration. This lecture covers fundamental knowledge most of you would know, particularly on mass to mole relationship and mole to volume relationship. Mass to mole relationship reflected by molar mass because molar mass is the mass of 1 mole of a substance. So the formula for molar mass is molar mass equal to mass divided by number of mole. From this fundamental equation, you can rearrange this to mass equal to molar mass times the number of mole, and number of mole equal to mass divided by molar mass. The second fundamental relationship is between mole and volume, reflected via molarity. Molarity is a concentration expressed as the number of mole of a substance in 1 liter of solution. So concentration equal to the number of mole divided by volume, and volume must be in liter. From this fundamental equation, we can rearrange it for number of mole equal to concentration times volume, or volume equal to the number of mole divided by concentration. As I said, these are fundamental concepts. Every of you should have no problem with these calculations. However, every year there are a few students who did not get this right. So I'd like to give a revision lecture on this. So for the calculation for the quantity of analyte from titration, in general, we know the amount of the standard. We have to calculate the amount of the analyte. The standard is given in terms of mass or volume of non-concentration. From the equation for the reaction, we see the relationship between standard and analyte. This is in terms of mole. Mole ratio we must use here. And finally, we calculate the amount of analyte, either in terms of mass or concentration, molarity, or percentage from the non-volume of the analyte. This is an example from the textbook. I strongly encourage every of you try to work out this question. These are the answers for this question. If you don't get the correct answer, you can view the next few slides for step-by-step calculation. I skipped the calculation here. If you need help, please post a message on the website or make an appointment to see me. Now, for acid and base titration, I would like to stress that the mole ratio we use is between acid and base from the neutralization reaction, not from H plus and OH minus. I have a few examples here for you to do. If you get every answer correct, then you would be okay. Otherwise, please look at the next few slides to know how the calculation should be done. Many people use equation concentration of acid times volume of acid equal to concentration of the base times volume of the base. Is this equation always true? We have to look at a few examples here. I'd like to go back to the concept that I stressed before, the relationship between acid and H+. As we said that the concentration of acid is not always equal to the concentration of H+. For monoprotic acid, 1 mole acid, 1 mole H+, then it's equal here. But for diprotic acid, 1 mole acid, 2 mole H+. The concentration of acid is not the same as the concentration of H+. Triprotic acid, 1 mole of acid, 3 moles of H+, so the concentration of acid is not equal to the concentration of H+. Similarly, we said that the concentration of the base is not always equal to the concentration of OH-. Now let's have a look at 3 reactions between acid and base. The first one, we have HCl react with NaOH. From the balance equation here, we see that 1 mole of acid react with 1 mole of base. For H2SO4 and NaOH, we have 1 mole of acid react with 2 moles of base. For hydrochloric acid and barium hydroxide, we have 2 moles of acid react with 1 mole of barium hydroxide. For the above 3 equations, the net equation is H plus OH minus give H2O liquid, meaning 1 mole of H plus react with 1 mole of OH minus. This net ionic equation does not tell us anything about the mole ratio between the acid and the base in the reaction. Therefore, it is much simpler, easier to do our calculation based on molecular equations. Now let's look at an example of the reaction between HCl and KOH. We have a titration in which we use 21.04 milliliter of 0.1045 mole per liter hydrochloric acid. We use 25 milliliter of KOH. We've got to determine the concentration of KOH. So for the calculation, we must use mole ratio. So first of all, we've got to know how many mole of HCl we have. So the number of mole equal to concentration times volume in liter. And then we look at the equation. We see the mole ratio here is 1:1. So this means the concentration of KOH equal to the concentration of HCl. Knowing the concentration, knowing the number of mole of KOH, knowing the volume of KOH, we can calculate the concentration of KOH. Our data is given in 4 significant figures, so we have to report in 4 significant figures. This method is called proportional calculation, that based on the proportional relationship between the 2 reactants, mole ratio here. If we use the equation concentration of acid times volume of acid equal to concentration of base times volume of base. The reaction here is 1 mole of acid, 1 mole of base. So we can use this equation. We rearrange it for concentration of the base, and we have the same answer as the previous method. The second question is on the reaction between sulfuric acid and KOH. Again, we have the volume and the concentration of sulfuric acid. We have 25 ml of KOH. The steps are the same as the previous example, but the mole ratio here is 1 mole of H2SO4 to 2 mole of KOH. So you see the number of mole of KOH is twice the number of mole of H2SO4. So we have to times by 2 here. And this is our answer. To use the formula CAVA equal to CBVB, we've got to be careful now. The ratio is 1 mole of acid to 2 mole of base. So we must have 2 CAVA equal to CBVB. We rearrange this equation and we have the same answer as our previous calculation. The third example we're looking at is 2 mole of HCl to react with 1 mole of barium hydroxide. So the ratio now is 2 mole of acid, 1 mole of base. If you use the equation CAVA CBVB, you've got to be very careful. Now we're looking at 2 moles of A and 1 mole of B. So the correct equation is CAVA equal to 2 CBVB. If you use the equation, it is very important for you to see the variation in the equation. If you are not very strong with this, I strongly recommend you to use the proportional calculation technique. Strictly, the equation CAVA equal to CBVB must be written as CH plus and VH plus equal to COH minus VOH minus. This equation is only correct for H plus and OH minus, or for acid and base reaction with equimolar, 1 to 1 or 2 to 2, not for 1 to 2 or 2 to 1. The principle here is we must understand that acid concentration is not always equal to H plus concentration, and base concentration is not always equal to OH minus concentration. There's some practice question for you on the website under volumetric analysis.